Hello, I hope this video finds you good. I hope you're okay. And I'm just gonna ask, how are you doing? I hope you're holding on so good. Thank you for tuning in. And today we are sketching a cubic function, a cubic function from a cubic polynomial. Let's just get into it. Y is equals to, let's say, minus 3 cubed plus 7x squared minus 15x plus 9. So this is a cubic function. This is 7. This is 7. Remember, I taught you how to to factorize a cubic polynomial. Then that is going to help us when we're looking for the x-intercept. So the first step when we are sketching a cubic function, we are looking for the turning point, the TP, or the stationary points. Why do I say points? It's points because we have two turning points in cubic function, unlike in a parabola where you have one. So how do we go about doing that? The first step is to determine the derivative, or f1 here, right? I showed you with the derivative and limits, and then after that you take the derivative and let it equals to 0, the second step, and then the third step you solve for x, and those x will be the x coordinates of your turning point. After getting the x coordinates of turning point, you get your y by substituting x into the original equation. So let's get straight into it. Then here the derivative y to its point 1, I don't know how they call this, but we're just gonna derive, we take the exponent, multiply by the coefficient, then it's gonna be minus 3 squared, no more cubed but squared, plus 14 x, no more squared but x, minus 15, right? Sharp. And then now we take this and let it equals to 0 is the second step. We let it equals to 0, then we just substitute. We're just gonna have this plus 14x minus 15 is equals to 0. Then a tip, it's very hard to say factorize, or now we're solving for x, right? But it's very hard to solve or factorize a negative a. Then we divide by a throughout by negative 1. This becomes minus 14x plus 15. Then in this case, then we have our two brackets, and then factors of 3 is just 3 and 1. X will just be x squared will just be x and x. Then we look for factors that might give us 15, of which is 5 times 3, 5 this side and 3 the other side. And then it's positive, the signs must be the same, minus minus, right? Then we solve for x. Here we say 3x is equals to 5, or x is equals to 3. X then becomes 5 over 3. We have our two x coordinates of the turning point. As I said, we have two turning points. Then to get our y, we take 3 and substitute here on the original function to get y. Then y into 3 gives us 0. I just did it prior to this video. And then as well, x, this one over 2. When we put it there, we get negative 32 over 27. Then there we go, you got your two coordinates for the turning point, which is 3 as x, your y is 0 for this one, and then for this one your x is 5 over 2, and then your y is negative 3, 2 over 27. These are your two turning points. We're just going to plot them, and then we take it from there, right? And then the following step then is going to be when you find the point of inflation. You need to find the point of inflation. It's very important as well when sketching the cubic function, right? Then the point of inflation, how do we get the point of inflation? We get the second derivative. We derive twice. And then after deriving twice, we let that derivative be equals to 0. After it is 0, then we solve for what? For x. And then we get the x value of point of intersection by so doing. Similar approaches, but we just derive twice here with turning point. Then we already derived once here. Deriving twice, the answer will be minus 6. Remember, it's minus 3 times 2 is 6. And then we minus 1 on the exponent, we're left with only x plus, this is 1 times 4. 14 is going to be 14. And then we have 1, we minus 1 is going to be x to the exponent 0. And x to the exponent 0 is just 1. That's why here it's 14 times 1. It's just 14. And then 15 doesn't have any x, so we just let it equals to 0. Then we take this and then we say the derivative now must be 0. Then we say the second derivative must be 0. Then we do as this way, and then we solve for x by taking 14 to the other side. It becomes negative 14. We divide with negative 6, divide with negative 6. Then we get our x being equals to, not xz, but x equals to what? Negative and negative becomes 14. To this side goes 7 times, and this side goes 3 times. That's our x for the point of inflation. Then getting y, we just put 7 all over 3 in the original function here. I haven't done it. Let's quickly do it. 7 over 3 cubed plus 7 over 3 squared minus 15, 7 over 3 plus 9. I'm doing it fast. I don't know if I did it correctly, but it's negative, it's 16 over 27. Then we have your point of intersection as what? As 7 over 3 minus 16 over 27. Point of inflation. Then we carry on. We need the y-intercept now. We need the y-intercept now. What's the y-intercept? Because it's y, we let x equals to 0 so that we get the y. We know x is 0, then we just substitute wherever we see x, then y becomes negative into 0 cubed plus 7 into 0 squared minus 15 into 0 and then plus 9. So anything times 0, it's 0, 0 cubed is 0, 0 squared 0, 0, then we have 9. So our y-intercept becomes what? Our y-intercept becomes, our x is 0 here, and then our y is 9. Sharp. And then now we are looking for the x-intercept. X-intercept, y becomes what? The y becomes 0. And then xy becomes 0. We go back to the original graph and let this y be equals to 0. Then we're going to have 0 is equals to negative x cubed plus 7x squared minus 15x plus 9. So now in this case, we are looking for the value of x's, meaning it takes us back to factorizing this because we can't solve this without then it's a matter of saying we look for a factor that will not be a reminder. We go back to that traditional thing of ours. If we put 3 here, we can get it from here. If we put 3, we get y is equals to 0. Therefore, x minus 3 is a factor. You can prove it by substituting 3 here and 3 here. It's going to give you 0. Then here we have 0 and the special, here we have 3 and the special 0 that we always start with. The coefficient above is minus 1, this one, plus 7, minus 15, plus 9. Then from here we go down, we are adding, it's minus 1, negative 3 times negative 3, negative 1 is going to be negative 3, 7 minus 3, as we add 7 plus negative 3 becomes 4, and then 3 times 4 it becomes positive 12, negative 15 plus 12 it becomes negative 3, negative 3 times negative 3 becomes negative 9, 9 plus negative 9 becomes 0. Then we see this is what we are looking for. Then we conclude by saying this is a factor already, we know x minus 3, and then on the other side we have this, which is minus x squared plus 4x minus 3. So this, it can replace this thing, it can replace this one, I mean to say. Then we already know this is side is equals to 0, and then solving for x, we can simply just say x is equals to 3, or our x is equals to, oh, this bracket needs to be factorized first. This bracket needs to be factorized. Fact, as I said, we can't factorize a negative figure here. Then we're gonna, let's just write it like this, right? Not is equals to minus 3 is equals to 0. Then when factorizing, we can't factorize a negative. A negative a we divide by negative 1 so that it becomes positive. And then remember, this signs as well changes because we're dividing everything with negative 1. And then it takes us to what? It takes us to having x squared into 2 brackets is equals to 0. We have x and x, 3 times 1 gives us 4 minus, right? And then our x-intercept, we end up with 1 is equals to 1, or x is equals to 3. So we have your y-intercept, your x-intercept, your turning point, your point of inflation. Now what's important is to check A. Check A is negative, it means our graph, it starts by decreasing. If, make notes of this, if your A it's negative less than 0, your graph will start by going down, reach turning point and go up and down again because it has 2 turning points. If then your A is greater than 0 or it's positive, your graph will start by increasing only the start. It's reach turning point, decrease and go up again, right? So in this case, our A is what? Negative. In this case, our A is less than 0, it's negative, it's going to be like something like this. So now let's draw it on a Cartesian plane. Here we have, this is our y, this is our x-axis, right? And it tells us that we have a turning point at x is 3 and 0. So here it's a turning point, this point 3 and 0, right? And then as well it tells us we have 5 over 2, 2.5, and it's a positive turning point, this positive turning point. 2.5, if this is 3, this is 2, this is 1, then 2.5 is here, 2.5, and negative 32 over 27, it's somewhere down here. Negative, our y is negative. This is A, let's name it, this is B. So this is A, and then this is B. These are both our turning points. And then our y-intercept is at 0 and 9. This is x0, 9, it's here. And then this is where it cuts, is this point, we call it C. It's point C. And then we have this one, which this one we didn't conclude, x and 0, 1 and 0, and then 3 and 0. And then we have another x3 and 0 again here, right? And then 1, it's here. Yes. And then it's just going to be, this is the turning point, it turns, it goes down, and this is the turning point, it turns and go up. And then here it cuts at 1 and 0. 1 and 0, it's here. I didn't point it, it's here. This we can call it point D. Point D. Look at this. 3 and 0. Even here we have 3 and 0. This way, this one. 3 and 0. So it's this point. And even this point, it's still there, what? The turning point. So it's a turning point, and this point is turning point, and is the x-intercept. This is just the y-intercept. This is only the what? The x-intercept. So how is our graph looking like? It turns here, and as well here it turns, right? And I told you that a is negative, so it starts by decreasing. So it's this one. So it's gonna start up here, go down, decreasing, and reach 1 here, and then curve at B because B is turning point, and then curve again at A because it's y-intercept and turning point, and then go down. So this is our cubic function in total. Thank you for watching. I hope I've explained in details and everybody understand. If not, please let me know and we'll fix it.